Okay, let's recap this one more time. I'm going to draw this in a rectangle so it's easier to understand. So I have the parabola which is 1 on 9x square, and I have this one which is 4x square, and I'm supposed to find this area. Of course, I'm going to double that area eventually to get the area that I want. So when I find this area, that area is nothing but integral of 0 to root 18, 0 to root 18 of that function 1 on 9 x squared dx, right? And this rectangle, the big rectangle, is 2 root 18. So the area, which is, I'm going to use the yellow color again to call this whole area. This whole area in yellow is nothing but 2 root 18, the rectangle, minus the integral of 0 to root 18, 1 on 9 x squared dx. Okay, now let's work on the other area. I'm going to erase all these bits. Okay, so let's work on this area. I know this one is 1 on root 2. Of course, that was plus 1 on root 2. So this rectangle, this whole rectangle is 2 on root 2. 2 times 1 on root 2. Now the area under this, which is this whole area, which I can denote with a different color. Let's call this area the green area. Okay, that area is nothing but 0 to 1 on root 2 of 4x squared. Okay, so correspondingly, using the same method, if I want to find this area, which is this area here, this area in gray, that area in gray will be found using integral of this taken away from the rectangle minus integral of 0 to 1 on root 2 4x squared. Now if I have to find this common area, let's go back to our, if I have to find this area, which is this area which I initially wanted to find, it will be found by subtracting from this whole area, which is this one, and take away this area, which is this one. Okay, that's what we are doing in this equation here. So let's simplify that one. Now it's a matter of simplification. So required area is equal to twice, let's leave the brackets, 2 root 18, and this is minus, this one is 1 on 9 x cubed divided by 3 from the bounds 0 to 1 on, sorry, this one is 1 on, sorry, it's not 1 on root 2, it's 18. I don't need this bracket, I simply need this bracket. Minus, I need to be careful here, there are minus and another minus, so we should be careful. So minus 2 on root 2, and this becomes plus, and I have to do this one. This integral is 4x cubed divided by 3 from the bounds 0 to 1 on root 2, close the bracket. In fact, these two brackets need not be the square brackets. I'm going to use these brackets so don't confuse with the integration upper and lower bounds. So let's leave this one outside. I get 2 root 18 minus, let's put that in bracket, this is 1 on 9, that is 1 on 27, that is root 18 cube, minus 0, minus 2 on root 2 is going to be root 2, simplify, plus bracket 4 by 3 into 1 on root 2 the whole cube minus 0, complete the bracket. So this is 2 bracket open, 2 root 18 minus, this is root 18 the whole cube, I'm afraid there's not much simplification here, plus 4 on 3, 1 on root 2 the whole cube, bracket close. You'll have to use the calculator, and I think the answer is 20 on 3 root 2 unit square. Okay, so that is the answer. There's another method that we can use. This method, finding the area under the curve and from x equal to a value a to x equal to value b, is in New South Wales syllabus. But there's another method which allows you to use area under the curve and the y-axis, between y-axis from y equal to a to y equal to b, and then your equation has to be in the form of y. So x equal to function of y, and then you have integration with respect to dy. So that one I can simply set it up like this. I can find this whole area under the curve, under the red curve, and then I can find this area and subtract that from the bigger area. So that can be done as well. That's another method. However, this is one method. It has got a couple of extra steps because you have to use the rectangle. So here you go. Please post any comments that you need, any questions, and thanks for watching.